Bismillahirrahmanirrahim. So we will discuss what do we mean by normal subgroup. So let H be a subgroup of G, then H is normal, and notation we write H is normal subgroup of G if X, so left coset and the right cosets formed with the H are equal for all X inside G. So you can prove that. What are some of the examples? If you are taking G as abelian and you are taking any subgroup of this G, then it is going to be normal. And you can also check that center of G is always normal. But now I have a result that I'll prove here. The result is this, that it says that, so it's a theorem which says that a subgroup H of G is normal if and only if X times xx inverse is sitting inside H for all X in G. So let's prove this result. For one side, let's assume H is normal. If H is normal, this implies that A times H is same as, so left and right cosets of H are same for all A inside G. My task is to show that X times xx inverse is sitting inside H. So there can be lots of ways, but I will do this way. I'll pick an element from here and I'll try to show that this is going to this side while using this. Okay, so let me pick an element. Let y be from xHx inverse, so my y must be of this form, x times hx inverse for some x, some h inside H, and for all X inside G. Now look at here. This assumption is saying that AH is always HA. So what I can do is, so this is showing me that XH can also be written as HX, because this is true for all A. So in particular for X as well, this is going to be true. So what I can write here is y is equal to h times x inverse, but this is identity, so y is h and this h is sitting inside H, so you can say that y belongs to H, right? So this shows that x inverse is sitting inside H, right? What's the next thing? So the next thing is this. So we assume now that xHx inverse is sitting inside H, and we will prove that H is normal. So proving normal is equivalent to saying that HAH is HA for all A and G. So we will develop this. There can be many ways. One of the ways could be to pick an element from here and take it to this side using this, and then pick element from here and take it to this side while assuming this. So this could be one of the way, but there can be other ways as well. Like for example, one of the easier way could be, okay, let's follow this. My task is to show that AH is same as HA. This is what that I want to show. So what I will do, I'll pick an element from here. Let y belongs to H. So this shows y must be A times H for some H inside H, right? But I can multiply both sides, y A inverse, so like taking with the binary operation, so inverse. Now this element is here and I know that this belongs to H, or this is subset of H. So if this set is subset of H, so this means this element which is here is also an H. So this is inside H. So this can be written as H prime, where this H prime is an H. So I can say that y A inverse is equal to H prime. Okay, but then I can write from here y equal to H prime A. Now this is showing me that y is inside HA. So I have picked an element from here and I have taken it to this side. So this is giving me that AH is actually subset of HA. Now let's pick an element from this side and take it to this side. So let now Z be an element from HA. So my Z can be written as H, so like H double prime A for some H double prime inside H, and then I can multiply both sides. If I multiply both sides with A inverse, okay, so A inverse times Z, A inverse times H double prime and H. But now you see that I can write this A inverse Z equal to A inverse and H double prime A inverse whole inverse, right? And then I see that this is an element and this is the inverse of that element, and in the between we have an element from H. So this element is over here. So this element is over here. And this is subset of this, so this whole element is also an H. So I can write A inverse Z equal to H triple prime, where H triple prime is some element inside H. And this shows that if I multiply A on both sides, then this is going to be this guy. And this shows that Z is going inside AH. We have taken an element from HA and it is an HAH. So this shows that HA is subset of AH. And from this and this, it shows that AH and HA are equal. So AH is same as HA. And this shows that H is normal. Thanks.